the two equations, the general form without the b and then the general form with the b. So previously in our notes, we talked only about these types of conics. Ax squared plus cy squared plus dx plus ey plus f equals 0. And again, the question is, where's the b? It's the coefficient to the xy term. There is no xy term, so we could assume that b is 0 in this case. And when b is equal to 0, there's no rotation, which means the orientation of your conic section is going to be either vertical or horizontal. So I've got a vertical major axis for an ellipse and a horizontal major axis for an ellipse, and those were really the only two different ways we drew ellipses on the coordinate plane up until this point. And we could say the same thing for like hyperbolas. You either have a horizontal transverse axis where your hyperbola opens left and right, or you have a vertical transverse axis where your hyperbola opens up and down. Okay, and then same for the parabola. Okay. The new equation that we're going to see today will have all the terms. So now b will not be equal to 0, which means the presence of the xy term is there. There is some xy, whatever that coefficient may be for b, it's not 0. And if you come across a general form equation that has an xy term, that means the conic is rotated. Okay. So we see an ellipse there that looks to be rotated somehow on the coordinate plane. Now, the issue with that equation as it is, if we tried our old method for general form, which is like to combine all the x terms, combine all the y terms, complete the square for the x's, complete the squares for the y's. In the second equation, if b is some number other than 0, does the xy term belong to the x's or the y's? And it kind of puts a wrench in our plans for rotating the conic. Okay, so that kind of throws off everything that we've learned up until this point. So here you would write this stuff in your notes. It's also in your book, but you should have it in your notes. These are the steps we're going to follow to rewrite that equation on the bottom of the screen so that it is something we can graph and we know what's happening to it. Okay. Oh, but that'll come in a little bit. I guess we have rules, and we talked about rules previously for like what shape the conic will be. If you remember, we did that at the very end of hyperbolas. We said if you have x squared and y squared, but one is positive and one is negative, then it has to be a hyperbola. If you have x squared and y squared and they're being added with different coefficients, then it's an ellipse. Okay. When the bxy term is present, those rules no longer apply. We won't be able to tell just by looking at the coefficients to the x squared and the y squared terms as to what shape it is. So we have to actually calculate b squared minus 4ac. Does b squared minus 4ac look familiar to you? What's it from? Distance formula? The quadratic formula, okay. Quadratic formula, and does anybody remember what that's called, the b squared minus 4ac? It has its own name. The discriminant. Okay, so this is the discriminant. And we can call it the discriminant for conic sections too. In quadratic functions, the b squared minus 4ac was in the quadratic formula. It's underneath the square root, and it tells us like how many and what type of solutions we have. If the discriminant is positive in the quadratic formula, you're going to have 2 real solutions. If it's equal to 0, you have 1 real solution. And if it's a negative number, you're going to end up with 2 imaginary solutions to the quadratic formula. Okay. The discriminant in this formula, or in this equation, will tell us what type of conic we have. So when b squared minus 4ac is less than 0, you know it's an ellipse or a circle. We won't know which one it is until we rewrite the formula. Okay. So we'll have to actually rewrite the formula before we decide if it's an ellipse or a circle. b squared minus 4ac equals 0, well then it's a parabola. And if b squared minus 4ac is greater than 0, it must be a hyperbola. We're going to use this on each of our problems. I suggest you do it just at the very beginning, do a quick calculation of the discriminant, and try to decide what shape it is. So that when you get to the end and you rewrite your equation in standard form, does that look like the standard form for a parabola? Or does that look like the standard form for a hyperbola? Okay, and you'll know if you've written your equation correctly. So I'm going to give you 3 equations to solve. You can use a calculator here to do your b squared minus 4ac if you want, or you could do it by hand, certainly. But if you would, just take a minute to classify these 3 conic sections. If I take a look at the first one, the coefficient to my x squared is 2, so that's my a value. The coefficient to my xy term must be 1, so that's my b value. And then coefficient to y squared is 2, so that's my c. So I would just calculate my discriminant off to the side. That would be b squared minus 4 times a times c. And that gives me 1 minus 16 or negative 15. So you would classify this as an ellipse or a circle. Excellent. Thank you, Sammy. Again, we can't say for certain at this moment whether it's an ellipse or a circle. We'll need to actually rewrite this equation to make our final decision. In the second example, we can do the same thing. Calculate our b squared minus 4ac. So this time we're doing 2 squared minus 4 times 1 times 1, which turns out to be 0. So this is a parabola. Thank you, Will. Whenever your discriminant is equal to 0, you have a parabola. On the last equation, all you have is a b term, an xy. So b is equal to 1, and we would do 1 squared minus 4. Since there is no x squared or y squared term, the coefficients are 0 for both of those. So we end with a positive 1 discriminant, which means that must be a hyperbola. So I'll call that step 1 of our process when we get to our very first example. We're going to go ahead and figure out which shape it should be so that at the end when we rewrite our equation, we know if it looks like the equation that we've studied previously in standard form. Any questions there? Okay, so here's the meat of what we're going to do today, and I would take the time to jot this down in your notes. Okay. If you see a general form equation that has an xy term, so ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. You automatically know that's a rotated conic because the xy term is present. We are going to rewrite it, and those are primes on all the variables. A prime x prime squared plus c prime y prime squared plus d prime x prime plus e prime y prime plus f prime equals 0. And by labeling it with all those primes, we're saying this is a new x, this is a new y, and these are the new coefficients for those terms. What's the big difference when you look at those two equations besides the primes? There's no bxy term, right? So there's no b prime, x prime, y prime. And that's like our number one goal when we're rewriting the equations. You'll know after you do all your algebra if you're on the right track, if your x prime, y prime are gone. Okay? If x prime, y prime remains, you probably have an error somewhere in your work and you want to go back and find it. Okay. So what we're going to do is we're going to rewrite things that have the xy term that have a rotation. We're going to rewrite them in a new general form so that we have no rotation. Then we're able to follow all of our old rules for writing that in standard form. Okay. And what this means is we will actually rotate the coordinate plane axes. So you know x is horizontal and y is vertical. We're going to figure out what angle theta is. That's going to be our angle of rotation. And we're going to rotate the original xy axis counterclockwise through that angle. And that'll be our new coordinate axes. They won't be horizontal and vertical anymore. We'll call them like x prime, y prime. Okay. Now, how to find angle theta? You can use one of these two methods. Cotangent of 2 theta is equal to a minus c over b. Or you could flip that to its reciprocal. Tangent of 2 theta equals b over a minus c. This means we'll have to call in our knowledge from the unit circle. So that unit circle we learned at the very beginning of the semester, we're going to need that so that we can do inverse tangents, okay, and figure out what the angles are. To give you kind of a visual picture of what I mean by all of this, I'm going to just sketch a coordinate plane that we know with x and y. That would go along with the equation that we have at the top. But we're going to rewrite that equation in those x prime, y primes, and we're going to find the angle of rotation, and then we're going to take like the x-axis, whatever the angle of rotation is, we're going to rotate it counterclockwise. So maybe the x-axis is now this x prime axis that has been rotated some number of degrees or radians. Okay. And at the same time that you rotate the x-axis, you should also rotate the y-axis the same number of degrees. And so we're going to have this new coordinate plane system right here where we're going to graph on the red axis instead of the black axis. And that's going to give us our rotation. Okay. So this equation that has all the primes goes along with the red axis. Okay. Now, the other thing we need in order to be able to make this happen is some substitution for the regular x and y. So by our angle of rotation, it will be true that our new coefficients will be obtained by the following substitutions. So I'll give you a minute to write those down. Double check to make sure you have the correct order. You have the correct sign, positive or negative on both of those. So what this is saying is, in that very original equation that has the bxy term, that's all in terms of regular x's and y's. We're going to go into that equation and replace all of those regular x's and y's with whatever we get in these two substitutions. So x is x prime times the cosine of theta minus y times the sine, or y prime times the sine of theta, and y will be x times the sine of theta plus, or sorry, x prime times sine of theta plus y prime times cosine theta. So just really quickly, it might be good for us To maybe do a quick little review of our unit circle, okay? In order to evaluate sine and cosine of the angle of rotation, we'd use the ordered pairs. Remember, cosine is x and sine is your y coordinate. Okay, so this point right here is at 1, 0. That would be our angle 0. We have an angle pi over 6, and its coordinate is square root 3 over 2. Thank you. 1/2. We have a pi over 4 angle with coordinates square root 2 over 2, square root 2 over 2. We've got that pi over 3 angle, 1/2 square root 3 over 2. And then you've got the angle up here that's pi over 2, which will be 0, 1. And then you could fill in the other quadrants. In order to figure the angle of rotation, you'd need to know the tangents of each of these. So, what is the tangent of a 0-degree angle? Or tangent of 0 radians? 0, right? Remember, tangent is y over x. So the tangent of 0 is 0. What's the tangent of pi over 6? Square root 3 over 3. What's the tangent of pi over 4? 1. The tangent of pi over 3? Square root of 3, and then the tangent of pi over 2, undefined. Okay, so those are good to kind of review so that you can then evaluate all the stuff that we have right here. Okay, so let's put it to use. We're going to do xy plus 2 equals 0. Well, we have all different terms if you want to know. First thing I want you to do is use your discriminant to figure out which conic section this is. Okay, so step 1, let's decide what conic we're actually working with. If I use my discriminant here, b squared minus 4ac, my b value is 1, my a and c are not there, there's no x squared or y squared term, so the coefficient must be 0. My discriminant is 1, so what shape am I working with here? Hyperbola, excellent. So we can be thinking in our head, at the very end of this process, we want our standard form to look something like the hyperbola standard form we studied in 10.4. That'd be like x minus h squared over a squared minus y minus k squared over b squared equals 1, or y minus k squared over a squared minus x minus h squared over b squared. One of those. Step 2. Find your angle of rotation. Now, you can use either little equation that I gave you there. I would say most people will probably have better consistent answers if you use the tangent, just because we're more familiar with the tangents on the unit circle than cotangents and having to flip them. So I'm going to plug into that tangent of 2 theta equals b over a minus c. Tangent of 2 theta equals b, 1, over a minus c, which is 0 minus 0. So we're saying that the tangent of 2 theta is undefined, right? And that means if you do the arctangent, what is 2 theta equal to? What angle has undefined tangents? Pi over 2. Okay? So if we think about doing the arctangent and solving for the angle, 2 theta must equal pi over 2. Which means that theta is pi over 4. So we'd have to divide by 2 or multiply by 1/2. So theta is pi over 4. If I'm thinking about that in terms of, graphically or visually, that means that where I have an x and a y axis on my normal coordinate plane, I'm actually going to rotate them to become an x prime and y prime axis. They'll each rotate pi over 4 counterclockwise. Okay? So my new x prime axis should be here, and my y prime axis should be here. And we're going to graph our hyperbola on the red axis, which will give us the rotation. Okay, so then step 3, we need to figure out what x and y are in terms of x prime, y primes, so that we can substitute them into that xy plus 2 equals 0 equation. So at the very bottom of what we wrote down on the previous slide, we have substitutions for x and y. Let's do those now. Okay. Find your substitutions for x and y. X will become x prime times the cosine of pi over 4 minus y prime times the sine of pi over 4. So you're using your angle of rotation in place of theta. And then we're using the unit circle. What is the cosine of pi over 4? Square root 2 over 2. What is the sine of pi over 4? Square root 2 over 2. So we're going to get square root 2 over 2 x prime minus square root 2 over 2 y prime. So that's going to be our substitution for x. And then we also have to figure out what's our substitution for y. So y equals x prime times the sine of pi over 4 minus y prime times the cosine of pi over 4. I love it when my angle of rotation is pi over 4 because the sine and cosine are the same, so that's pretty easy for me to do. Oh, this should be plus, sorry. Plus, right? And so this one will be the square root of 2 over 2 x prime plus square root of 2 over 2 y prime. Any questions or clarifications that I can talk about before we start plugging into the formula or into the equation? Okay, so if you go back up to the original problem, and you guys have it on your paper, we're going to take xy plus 2 equals 0, and we're going to substitute in for x, square root 2 over 2 x prime minus square root 2 over 2 y prime. And we're going to multiply that by our new substitution for y, and then write out the rest of the equation. Plus 2 equals 0. Okay, so I'm going to make my substitutions down here. To me, when I make that substitution, that still looks like x times y plus 2 equals 0, but x and y are now written in terms of x prime, y prime, using my angle of rotation pi over 4. Now, this is the part in the homework where you have to be really careful from here on out. One tiny multiplication sign mistake that you make could lead to a wrong answer, which those tiny mistakes get really frustrating. Okay, I know because I made them when I made my answer key. So I know what kinds of things can happen. Don't try to squish everything too small, too close, so that you can't keep track of things. Give yourself space to work on it. This one won't require as much room as some others might. But you're just going to have to take your time and go slowly and make sure you're doing it right as you go along. So what we're going to do next requires a lot of patience and a lot of careful checking. We're going to multiply these things together. Okay, through distribution, you might call it foiling. We're going to multiply that out. So we're going to start with our first terms here. The square root of 2 over 2x prime times the square root of 2 over 2x prime. What is the square root of 2 over 2 times the square root of 2 over 2? 1/2. It will be 2 over 4, which reduces to 1/2. Okay. So we could write that out as 1/2 x prime squared. Now, you'll see that I write my x primes and y primes that are squared in a group of parentheses. If I just write x prime squared, to me it looks like 12. So I don't like that, so I have to have a parenthesis there. And then you keep going. So now I'm going to do my outside terms on the parentheses. The square root of 2 over 2x prime times the square root of 2 over 2y prime. 1/2 x prime y prime. Now I'm going to do the inside terms, okay, in the parentheses. Negative square root of 2 over 2y prime times positive square root of 2 over 2x prime. A negative times a positive will be a negative. This one works out so nicely, like I said, with pi over 4, because each time it multiplies to give us 1/2, right? And then some people might say y prime, x prime, but I always write them in alphabetical order. It's multiplication, so it shouldn't matter what order I write them. So I'm going to write that as x prime, y prime, because then it matches. I can easily see what's a like term there. Now we have one more to go. Negative square root of 2 over 2y prime times positive square root of 2 over 2y prime. That's a minus 1/2 y prime squared. Plus 2 equals 0. Now, what you notice happens that is very good for us. Yeah, x prime, y prime cancels, which is what we want to do, right? If you have an x prime, y prime left over at this point, you know you've made an error because you haven't eliminated the b term, okay? So always these things should cancel. And the rest of our work is really just simplifying. So I'm going to say that this 1/2 times x prime squared, I'm going to write that as x prime squared over 2, if you're okay with that. Isn't that the same thing? And then I have minus y prime squared over 2. And to get it closer to standard form, this plus 2 I'm going to move to the other side. Okay, so subtract 2 from both sides, so I get a negative 2 over there. And I'm starting to see what is looking more like a standard form of a conic section. But in standard form, the right side has to be equal to 1. So I'm going to divide the whole thing by negative 2, or you can think about it like multiplying everything by negative 1/2. Okay, so I'm going to, because I have those fractions on the other side, I'm going to multiply this whole equation by negative 1/2. When I distribute that negative 1/2 through my whole equation, it'll make my very first term, x prime squared, negative, and now it'll be negative x prime squared over 4 plus y prime squared over 4 equals positive 1. And I'm so close to standard form. What should I do to make it look like a standard form? Switch those two fractions, right? I could have done that in the last step all at once, okay? But in a hyperbola, the positive term should always come first because then you know what a squared is, okay, and what your transverse axis will be. So then I should switch them. This is really y prime squared over 4 minus x prime squared over 4 equals 1. And other than the fact that they're x primes and y primes, this looks like a standard form. Where's the center on my x prime, y prime axis going to be? At 0, 0. My a squared value is 2, and my b squared value is 2. I can use that to help me draw a graph. So the last step we'll do is graph. I already kind of got us going on the graph when we did the angle of rotation. On your graphs, like on a quiz or a test, I won't give you a coordinate plane on these because you're actually going to draw the rotated axes. So remember we had a pi over 4 rotation, that's 45 degrees. So we have our new x prime and our new y prime. And you're actually going to graph on the red axes. I'm going to see if I can drag. Oop, I got to put my marker down. One thing I would suggest for you guys to do is to take your papers and rotate them so that now the x prime, y prime axis, it's probably thinking it's mad at me and pushed too many buttons. So now the x prime, y prime axis is like perpendicular in front of you, and right up like the x, y would normally be. And then you're going to graph from there. So like we said, the center point was at 0, 0. And the a value was 2, and it's paired with y. So on that y prime axis, you'll count up 2 and down 2. I'll just graph on the slanted one. So like I said, you would count up 2 and down 2 on the y prime for your a. So like there's a vertex. Here's a vertex point. So I know now that my hyperbola is going to open around that y prime axis. You can still use like the b value since b squared is 4. B is 2, so you can count on the x prime axis, right and left 2. And I'd like you to make the box and the asymptotes, but after that you don't have to do anything more. So you don't have to find the foci on this one. Okay, so I would make my box with my a's and my b's. I would make my asymptotes. This one should be on the x-axis. And then remember, your transverse axis is your y prime axis. So make sure you draw your hyperbola opening with the vertex points, the a's. I would start at that vertex and I would follow my asymptote. Like so. So I'm opening around the y primes. I won't ask you to like label this new point because it's not going to be at like 2, 2 or anything on the real coordinate plane. You'd have to like switch it back into the regular xy's. So So we're not going to ask you about the actual coordinates for those points, although that's something you could do later, okay, if you saw this again. If you train your eyes to focus on the black axes, the x and the y that we started with, and then you look at your hyperbola in relation to the black axes, you can see that your hyperbola is rotated. If you focus your eyes on the red axes, the new axes, the x prime, y prime, then the hyperbola doesn't look rotated on those axes. Are we okay with this? Okay, so what we're going to do next is we're going to start the homework. And we're going to do a problem, one of the longer ones, step by step, and kind of check in with you as you go and make sure that you're getting the right answers. Okay, so that we can check and make sure we're on track. So at the end of this, you'll have 1 of 4 homework problems done, and then you'll have time to get started working on the other ones. So the first one we're going to do is, it's from page 729. It's number 19.